Okay, so now with x to the third plus 216, pause this video and see if you can factor this perfect cube yourself. Okay, now that you paused it, you should have already tried to factor this. You need to ask yourself, is my first term a perfect cube? Yeah. I can cube root x to the third and then square it. Is 216 a perfect cube? Yeah, for sure. I can cube root 216, meaning 6 times 6 times 6 is 216, square it. Now, this is a positive, that means this is a positive and my middle term is a negative. 6 times x is 6x. So this in blue is this factored. If you were to multiply this whole thing out, you would end up getting this binomial right here. Look, the cube root of x squared, which is your a, and then square it. The cube root of 216, which is your b term, squared. The binomials are the same. The trinomial middle sign is different. The middle term is the product of your two a and b in your binomial. That's the Mathenese explanation. Hopefully that made sense to you guys. Now, what I'm going to do is look on the next thing of notes where it says find the roots of x to the third. I want you guys to pull out your graphing calculator and see if you can find the roots of x to the third plus 125. If you were to factor x to the third plus 125, this is what it would look like. X to the third plus 125. If you were to factor it, I'm going to do this one a little faster. The cube root of x to the third is x squared. The cube root of 125 is 5 squared. The binomials are the same, the trinomial is different, and this is the product. Okay. Now, one of the roots of this would be a negative 5. That would take care of that, because if I set it equal to 0, the question is, what are all the roots to this? If you graph this on your graphing calculator, you're going to see that it has 3 roots, because this is x to the third. You remember from last class, this is going to resemble some type of graph that looks like this. And on your x-axis is going to look something like this, where it's going to be 1, 2, 3 different roots right here. I don't know exactly where, but I can figure out that this right here is going to have 2 roots. I don't know 2 numbers that multiply together to give me positive 25 and add together to give me negative 5. Those 2 numbers don't exist. So when those 2 numbers don't exist, but you know it's factorable, you use something called the quadratic equation. I'm not going to do that, but if I use the quadratic equation, what I would end up getting is 2 different roots. And then I would have my 3 roots. Now, coming back, and I'm kind of rounding everything back to the very beginning of this lesson. The very beginning of this lesson, I asked you, or I gave you a polynomial, which I'm going to write out. I'm going to pause this video, or I'm going to have you guys pause this video. I'm going to redo this question using synthetic division and then factoring cubes to answer my original question. So, my original question, also in the notes it says factor 8x to the third minus 1, and I give you the steps. I say number 1, factor it, set it equal to 0, and solve. Okay, so what I'm going to go back and do, I'm going to ask you this. I'm going to say, with this polynomial, f of x equals x to the 4th minus 8x minus 3x to the 3rd plus 24. The question is not only factor it, but find all the roots without using your calculator. Meaning don't plug this in your calculator. We're going to use synthetic division. We're going to use factoring cubes. And we're going to use probably the quadratic equation, you'll see in a second, to find all the roots. If it tells you one piece of information, it's going to tell you one of the roots is 3, comma 0. That's one of the roots. Now, pause this, see if you can find the factored form of this using synthetic division. Take the factored form and solve and see if you can set it equal to 0 and find the roots as well. You probably have to use quadratic equation. This is going to probably take you about 4 or 5 minutes to do. Okay, go ahead and pause it and see if you can find the roots. Okay, now that you should have paused it, and we already know one of the roots, which is 3, comma 0. And I'm going to put my roots right up here. So 3, comma 0 is one of my roots. Now, what you should have done is rewrote this in decreasing order, starting with x to the 4th. Negative 3x to the 3rd has to come here. It has to go in decreasing order. Notice I don't have an x squared, but I still have to literally state that I don't have an x squared. Minus 8x plus 24. This in blue is the same thing as this in red. Hopefully I haven't lost anybody yet. Hopefully, not yet, but hopefully I haven't lost anybody. I'm doing this. This is the exact same question we did in the beginning, but hopefully you can tie this together and it can make sense now. So now, using synthetic division, I'm going to figure out what this broken down more in factored form would be. Because I want to use the factored form to see if I can do anything else to find roots. One of the roots is 3, so I'm good. But I'm going to use this 3 on the outside of my Mambo Jumbo synthetic division. Now I'm going to list the coefficients. I have an invisible 1. I have a negative 3. I have a plus nothing, 0. I have a negative 8. And I have a positive 24. This is set up with synthetic division right now. Okay. I'm going to get rid of all of this. Just so it cleans it up a little. Not as much numbers to look at. Now with synthetic division, the very first term you bring down is 1. Why am I doing synthetic division? Because this is the broken down factored form even more. 3 times 1 is 3. Remember, you multiply these two, add the rows. Multiply these two, add the rows, and so on. Negative 3 plus 3 is 0. 3 times 0 is 0. Add the rows. 3 times 0 is 0. Add the rows. 3 times negative 8 is negative 24. Add the rows. This is my remainder. Now, if you had a remainder, you would just put this divided by whatever you factored. So if 3 is your root, it would be divided by x minus 3, because you just have to write this. In your denominator, you would write the factored form. Anyways, this is 0, so we don't have to put plus 0 as a remainder. Now I'm going to clean this up. I had x to the 4th, so that means this is x to the 3rd, this is x to the squared, this is x, and this is my coefficient. Okay, cleaning this up more, I have x to the 3rd plus 0x squared plus 0x, because 0 times anything is 0, minus 8, and I don't have a remainder. Okay. Now, why is this important? Because this is the next factored form. So far, let me kind of mentally go through this. If I knew my root was 3, the factored form before I found out that my root was 3 would be x minus 3. So technically, this is the factored form so far of the long polynomial of x to the 4th minus 8x minus 3x to the 3rd plus 24. This is the long factored form of it. Okay, I already know that the root of x minus 3 is 3. The whole point was to find the roots. Now, this is where we had to stop in the very beginning of the notes. But the good thing is, we ain't got to stop anymore. We ain't got to stop anymore because we know how to factor this now. Because this is a perfect cube. And with perfect cubes, you just learned how to factor perfect cubes. So synthetic division is used to figure out the next step in the factored form. That's what we use synthetic division for. How do I factor this? Cube root of x to the third is x squared. The cube root of 8 is 2 squared. This is the same binomial, and this is the opposite sign. This is the product of your two terms in your binomial. Okay? Cool, right on. I'm almost done. Now, can I figure out another root in here? Yeah, for sure. So another root would be if I set x minus 2 equal to 0, I would have a root of 2 comma 0. So I have two roots that I've figured out so far. Now all that's left is factoring this trinomial. Because once I factor this trinomial, I have my roots, boom, I'm done. There's no two numbers that multiply together to get 4 and add together to get 2, so I have to use a quadratic equation. I'm going to do the quadratic equation rather quickly. So I'm going to say x equals negative b plus and minus the square root of b squared minus 4 times my a times my c, all divided by 2 times my a, which is 1. All right. So I have negative 2 plus and minus the square root of 4 minus 16 all over 2. So this is going to give me two imaginary solutions. Anyways, you would say negative 2 plus and minus the square root of negative 12 all over 2, which you can convert this to negative 2 plus and minus I root 12 over 2. You could simplify root 12 to say negative 2 plus and minus, this would be, I'm simplifying this rather fast. This is a STEM class. You guys should understand that square root of 4 times the square root of 3 is 12. Square root of 4 is plus and minus 2. Which gives you here, you can cancel all three of these and you would say negative 1 plus and minus I root 3 would be your other solution. So that quadratic has two real solutions, which is at 3 and 2. That not quadratic, that polynomial, the original polynomial, I told you it had 4 solutions. However, you just found out that 2 of these are real, 2 of these are non-real solutions. So this is your 2 non-real, be negative 1 plus I root 3, negative 1 minus I root 3, and then also 3 comma 0, 2 comma 0. Okay, so your assignment that you have is a worksheet. The worksheet, I don't think there's anything this in depth, but you might have a couple questions like this on the test. On the worksheet, I don't think I give you anything this in depth, but you should be able to handle it now should you see it on your test next week. All right, thanks guys.